Chapter 2, Lesson 2 of Pre-Calculus, looking at power functions and graphing these power functions. So I have on the screen here the two-step process that we talked about, and then the 3 steps that we'll use in order to do this. So let's go ahead and do an example. So here's our first example. We have f of x is equal to 3 times x to the 1/4 power. So here's the 3 steps we want to go through. So we want to look and figure out what k is, and then use that to graph the point 1k, and I'm either going to be in quadrant 1 or 4. Now k here is a positive 3, so the point 1,3 is going to be on my graph, and the point 1,3 puts us in quadrant 4. Quadrant 1. Oh, I don't know why I said 4. Then we want to look to figure out the shape. Now again, the shape says if a is between 0 and 1, this is a fractional power, so if a is between 0 and 1, it's shaped like this root function. All root functions are shaped like this. And again, the higher the exponent, the higher the power, the more flat it'll be through here, but it will go through 1,3. So we know it's going to have this shape in quadrant 1. We then need to figure out if it's odd, even, or neither. And to figure out if it's odd, even, or neither, we substitute in negative x into the expression. Now, this is an even root. It's a 4. The denominator is the index of the root. Because this is even, we can't have negative values in, so substituting in negative x is impossible. So this would be neither, so I'm not going to have any values to the left of 0 because we're undefined down there. All right? So that was a very quick talking about it. Let me go ahead and write down, and we'll do some examples here and see if we can't. We'll do a number of these, and you can watch as many as you'd like. So here I have 7 examples. I'll do all 7. You can watch as many as you need. You can kind of fast forward through and get to one that looks maybe that you might not know how to do. So you can use this video to your own discretion as to how many you want to watch and how much you want to do. All right, so we'll do the first one here, and again, we'll follow our 3 steps. We need to find out k, so 1k is going to be on the graph. And in this case, our k is a -1, so the point 1, -1 is going to be on the graph. So these are all listed as 1 here. So let me just go ahead and put that on here. All right, so for this first one, 1, -1 is on the graph. So I would like you to label the 1k value, if you would, please. So this is the point 1, -1. Okay, 1, -1. Then we want to figure out what the shape is and if 0, 0 is on the graph. Now, because this is a negative exponent, 0, 0 is not on the graph because the graph is asymptotic to both the x and the y-axis. So I'm going to go ahead and graph the asymptotic portion of this, and this might take a little. Okay, so it's going to get close to these, but it's not going to touch either one of these. So this is going to be asymptotic to both. Okay. Then the last step is to figure out if it's odd or even. If it's even, we're just going to reflect that side of the graph over, and it's going to be exactly the same on the other. If it's odd, we're going to just turn that around, so it's going to imagine that being 180. And if it's neither, then we're finished. This will be all the graph that we looked at. So again, to determine if it's odd or even, we need to substitute in negative x into the expression and then simplify it and see if we get the same function or the opposite function. So I'm going to first rewrite this using a positive exponent. So negative x to the -4th we can rewrite as the opposite of 1 over x to the 4th. We move that down in the denominator. Then, here's the bell. Junior high is going to lunch. All right, so then we're going to substitute now in negative x for each x. So negative x to the 4th. Then we're going to simplify this. So that's going to be -1. And then a negative to the 4th power is going to be positive. And so this is going to be x to the 4th. And now if I move that back up in the numerator, I've got negative x again to the -4th. So when I substitute in negative x, I end up with the exact same function that I began with, meaning this function is even, which means the graph is going to be reflected over the y-axis. So this point here, 1, -1, is going to be reflected over, so I'm going to have this point here as well. And this whole graph is just going to be folded over. So this side of the graph I didn't mean to go up there. Well, let me do that again. I'm working on this this pad down here, and it's kind of difficult to copy actually. So this is going to be reflected over the y-axis. So what's on the left side is going to look exactly as what's on the right side. So this would be the graph of f of x equals negative x to the negative fourth power. And if I click on this, I should get a shape, and you see I'm pretty close. It's, you know, as to what we're doing. I do have basically the shape that we want. Okay, so I'm going to work my way down. So we'll do this next one here. So negative 4x to the 2/3. All right, so again, we want to go through our steps. We want to figure out k. K is what here? Negative 4. So 1, negative 4 is going to be on my graphs, which puts me in quadrant 4. So I go over 1 down to negative 4. So 1, negative 4 is on the graph. Okay, that's y1k. Now the shape. This is a fractional exponent. It's between 0 and 1, so remember it looks like a root function, but remember it's down in quadrant 4. So our root function, you remember, looks like this, but because we're in quadrant 4, then it's going to be reflected over, so it's going to look like that. So I'm going to try and draw that. And 0, 0 is on the graph because it's not negative, so 0, 0 is on the graph. So this is going to come down. Again, I'm having trouble with this because I'm working on my lap here trying to draw this, but this is going to come down and it's going to go through here and it's going to curve out this way. Okay, I'm going to have to find a better system. Matter of fact, hang on a second. I'm going to adjust things and see if I can't do this because that's just not very good. So let me do this. I'll do that. Alright, so let me put this up here and see if this helps me. Alright, so this is going to come down, that's a little bit easier, and look like this. Okay, so that's the root function. So that takes care of the 1k and the shape. Now I need to figure out, is this odd, even, or neither? So again, I need to put in negative x. So whenever you have a fractional exponent, you want to turn it into its root form to kind of do this. So the index is the denominator, so this is the cube root of, and then we have x, and then this is going to be squared. So now I need to substitute in negative x and then simplify it and see what I end up with. So this is going to be the cube root of, and then I'm going to put in negative x, and then I'm going to do squared. So if I simplify that, then I got negative 4 cube root of, and then that negative x squared ends up being x squared. Now if I rewrite this back as a fractional exponent, I've got negative 4x again to the 2/3. So I end up with the exact same function that I began with, meaning that this function is even. So that means even's reflected over the y-axis, so it's going to look exactly the same on the left side of the axis as it does on the right. So this 1, 4 is going to be reflected over here, so that's going to be here. And then the shape is going to look exactly the same on this side if I just reflect this over, and it's going to look like that. So this would be the graph of the function negative 4x to the 2/3. And we click on this, and you can see that I'm pretty close to what we wanted to have. Okay, f of x is equal to negative 2x to the 4/3. So again, the first thing I want to do is figure out 1k. The k here is a negative 2, so 1, negative 2 is on my graph. So I'll do that, 1, and I'll label it. And then, now it looks like it's a fractional exponent, but be careful here because this is 4/3, and actually 4/3 is bigger than 1. So I have an a value that's larger than 1, so remember that's going to look like that quadratic, and it's going to be just a little bit bigger than a line, so it's not going to be real flat there. So again, we're in quadrant 4 though, so instead of going up, this is going to look like a quadratic kind of halfway down, so this is going to look like this. Okay, sorry, there we go. Okay, so 1, 2. And because it's not asymptotic, 0, 0 is also on the graph. So now I need to determine if it's odd, even, or neither to determine whether I reflect it around the origin or reflect it over the y-axis or neither. So again, I'm going to substitute in, after I write it in its form here, this is what this looks like, and now I'm going to substitute in negative x. So negative 2 cube root of, and then I got negative, whoops, I don't know why I'm trying to write 4 there, negative x, and then to the 4th. So that's going to be negative 2 cube root of negative x to the 4th power just ends up being x to the 4th. And then if I rewrite that now in its fractional form again, I'm going to have 4/3. So again, I end up with the exact same function that I began with when I substitute in negative x. Therefore, the function is even, which means it's a reflection over the y-axis. So this point is going to be reflected over here, and the graph on this side is going to look exactly like the graph on the other side. So this is going to look something like this. So that would be the function f negative 2x to the 4/3. And if we click on that, hopefully we have that correct. Okay? All right, I'm going to do f of x equals 0.5 x to the negative 3 next. Okay, in this we're going to look at 0.5 x to the negative 3. So we're going to do step 1. We need to figure out k. 1k is going to be on the graph. K here is 0.5. So the 0.1 and then 0.5 is on the graph. So this is 1 and then 0.5, or you could write a half if you'd like. It means the same thing. We then need to figure out the shape. This is a negative exponent, which means it's asymptotic to both axes. So this is going to not ever touch the y-axis. It's going to come down here through this point here, and then it's going to be asymptotic to the x-axis as well. So it's going to look something like this. Okay, so it goes through that point and goes through. Again, it should be more of a curve. Sorry about that. I need to find a bigger workspace so I can be better at writing these things, but I'll work on that for future videos. Then we need to figure out if it's odd, even, or neither to figure out how to reflect this, if at all. So again, I'm going to take 0.5, and then I'm going to move the exponent down into the denominator so it's positive and I can work with it. And then I'm going to substitute in negative x. So, and now this is going to be negative x cubed. So this is going to be 0.5 then times, I didn't write parentheses before, but I'm going to write it now. Negative x cubed is negative x cubed. So now when I multiply this, positive 0.5 times this negative fraction, I'm going to get negative 0.5 times 1 over x cubed. Now if I move that back up into the numerator, I've got negative 0.5 x to the negative 3. So when I substitute in negative x, I get the opposite of what the function was originally, which means it's a reflection around the origin. So what we're going to do here is we're going to take this graph and we're just going to turn it 180 degrees. So this point is going to be turned around the origin 180 degrees, so it's going to end up right here. And so then the graph is going to be over in this quadrant here. And again, I apologize for not being able to draw very well on here, but I will work on that and I'll get better moving forward, I promise. I will work on it. Okay, so it's a reflection around the origin because the function is odd. So this should be what our graph of our function looks like. And there we go. All right, I'm going to do negative x to the 0.8 next. So if you want to hang around and watch that, you can. All right, negative x to the 0.8. Now this is interesting because it's a decimal, and we're not used to working with decimals because we want to look at the size of it, and we need to know if it's in a root or not, and that's based upon the denominator of fraction. So to handle that, you simply turn this into a fraction. All right, that's all you have to do. So negative x, now let me put this in white here so you can see that a little bit better. So we're going to have negative x, and then to the 0.8, 0.8 is actually 8/10, which divided by 2 gives us 4/5. So this is actually negative x to the 4/5 power. All right, so now we know that, let's just go ahead and do our steps. So we take our steps, so 1k is on the graph, so 1, -1, k here is -1, so we're in quadrant 4. So 1, -1 is on the graph, so let's go ahead and put that right here, label that. And because this is a fractional exponent, it's between 0 and 1, it looks like that root function. So the root function, remember, goes up like this, but it's down here, so it's going to look the same. So it's going to look something like this as it goes out. Okay. Now we need to figure out if it's odd, even, or neither. Now, it is a root function, but the index is not odd, it's not even, so it is defined for values less than 0. So we can go ahead and substitute these values in. So this should be negative out here, or the opposite of the fifth root of x to the 4th. So let's go ahead and substitute in negative x then. If we substitute in negative x, that's negative x to the 4th power. And then if we simplify that, we're going to get negative the fifth root of x to the 4th, then which gives me, if I turn it back into a fraction, negative x to the 4/5 power. So when we substitute in negative x, we get the exact same function that we began with, which means it's even. Even is a reflection of the y-axis, so however it looks on the right side of the axis, it's going to look exactly the same on the left. So this point is going to be reflected over here. 0, 0 is on the graph because it's not asymptotic, and then it looks the exact same over here. And so this should be the graph of negative x to the 0.8 power. And we'll click on here, and we're pretty good. Okay. All right, negative 2 x to the 1/4 power. Again, we have a decimal here, so we'll want to turn that into a fractional exponent moving forward. But we can go ahead and deal with it as it is right now. 1, -2, k is on the graph, so 1, -2 is my graph. So I want to, again, make sure you label that. Then the exponent is bigger than 1, which means it looks like that quadratic, only flattened out. So because it's in quadrant 4, 0, 0 is on the graph because it's not asymptotic, so it's going to look something like this. Okay, now I need to determine if it's odd, even, or neither, and here's where I will want to turn that decimal into a fraction. So that's 14/10, which if we 14 tenths, if we divide it by 2, we get 7/5. So this is actually negative 2 x to the 7/5 power. So then we want to go ahead and turn that into its fractional form, its root form. So this is going to be the fifth root of x to the 7th. Then I want to go ahead and substitute in, I'm going to scroll this up a little bit, try to work this one. So a little bit easier. So this is going to be negative 2 then, and then the fifth root of, and we're going to put in negative x to the 7th power. So when I do that, I've got negative 2, the fifth root of negative x to the 7th. Now, because this is an odd index, I can take the fifth root of this negative sign, which actually ends up being a negative. So that negative is going to come outside, and because I already have a negative out here that I'm multiplying together, this is actually going to become a positive. So fifth root of x to the 7th. So what I did was, this is the same as, just let me kind of explain that a little bit, the fifth root of, and what I did was I put negative 1, whoops here, I took this negative x to the 7th and kind of broke it apart into two parts, because this is the same thing. Negative 1 times x to the 7th. Now if I take the fifth root of negative 1, that is negative 1. The fifth root of negative 1 is negative 1. The fifth root of x to the 7th, I'm just going to leave it there. So that's why the negative sign comes outside. But then I already had a negative 2 out here, so the negative 2 times this negative becomes the positive. That's why it becomes like that. So then I'm going to rewrite it in its fractional form. So that's going to be 2 times x to the 7/5 power. So when I substitute in a negative x, I get the opposite function that I began with, which means I have what? I have an odd function. Whoops, let me get that out of your way. I have an odd function, which means then that it's reflected around the origin. So I can move this. Let me scroll back up here. There we go. So that means I take this graph that I have on the picture and I rotate it 180 degrees around. So this 1, -2 is going to be rotated 180 degrees, so it's going to end up being here. And then this picture up in this quadrant is going to look the same as the one that's down here. So this is going to look something like this as we reflect that around the origin. Okay, so we'll click that, make sure we got it. You see them pretty close. Okay, I've got one more to do. I'm going to do f of x is equal to 2/5 x to the 5/2 power. So if you want to stick around, you can watch that one. Okay, the last problem here, f of x is equal to 2/5 x to the 5/2 power. So again, 1k we're going to do first. 1k is on the graph, so 1 over 1 and then up 2/5, which again is somewhere in here between 0 and 1. So I'm just going to go ahead and label that point. So that's 1 and then 2/5. Then I need to figure out the shape. This fractional exponent, though it's a fractional exponent, is larger than 1, so it's going to look like that quadratic kind of in that first quadrant, only stretched out between 0 and 1, so it's going to look something like this. And again, we're just sketching these, so it's not going to be exact, but it's just going to give us a picture of what these are going to look like. Then I need to determine if it's odd, even, or neither. Oh, by the way, 0, 0 is also on the graph because it's not a negative exponent. So odd, even, or neither, so it's going to be 2/5. I'm going to change this into its square root of x to the 5th. I'm then going to substitute in negative x. So this is going to be the square root of negative x, whoops, negative x raised to the 5th power. So that's going to give me 2/5, the square root of negative x to the 5th. Now I have a problem here, is because when I raise this to the 5th power, this is a negative value underneath here, but because it's a square root, I can't have that. So this is actually undefined for values less than 0, so it's not a reflection anywhere. So what I have on my graph here is the graph of this function. It won't be anything else. Okay? So I hope those examples were helpful for you, and if you need to, just watch them over again, and we'll see you in class.